Welcome to the session on data types. As part of C fundamentals, we are going to discuss data types. What exactly is the data type? What exactly is the data type? What are the uses of a data type? And what are the data types supported by C language? And in what circumstances these data types are used? For what purpose these data types are used? So data type has two things. One is domain of values. What are the values that data type can take? So say if it is an integer, what are the possible integers? What are the possible integers? And set of operations that can be performed on those values. Set of operations that can be performed on those values. So domain of values. Domain of values means what are the possible values? What are the possible values? Remember, computers have their own limitations. So in general, integer means you can take from say minus infinity to infinity. Definitely you cannot take fractional values. You cannot take fractional values. So in general, you can take from minus infinity to infinity. But computer has its own limitations. It has its own storage capacity. So because of it, the number of bytes that can be used to store the integers or other data types also will be limited. So that's why we have to bother about the domain of values. There are only finite number of possible values. What are those possible values? Is defined by the data type. And also the operations that can be performed. So now suppose if they are integers, what are the operations that you can perform? Addition, subtraction, multiplication, etc. But definitely you don't concatenate the two integers, say 123, 576. You don't concatenate them, say to form 1, 2, 3, 5, 7, 6. Concatenation is not permitted. So if there are alphabets, so A, B, C, D, etc., you don't perform numerical operations on them. So data type is both the domain of values and the set of operations that can be performed on those values. So C language has three types of data types. It supports three types of data types. Not two actually, it is three. Three types of data types: basic data types, derived data types, and user-defined data types. Basic, derived, and then user-defined data types. The basic data types are those which are directly defined by the language. They are fundamental data types supported by the language. Derived data types are those which you can derive from the basic data types by combining them. How we combine, we'll see. But by combining these basic data types, you can arrive at the derived data types. Whereas user-defined data types are those which are defined by the user. They are not directly supported by the language, but please note that it's not that you are going to create new data types actually. You will be again combining these already existing data types to arrive at the new data type. So to be frank, you cannot create actually new data types in C language. There are no user-defined data types. But the only thing is you will give new name to the existing data types. And what is that? What is the use means? It conveys more meaning. Appropriate meaning. We'll see. We can do it using the result word called as type def. So these are the basic data types supported by the C language: int, float, double, char. These are the only four data types that are supported by the C language. Of course, you can define new data types also, like string can be defined. String can be defined by making it as a collection of characters. How to define the strings we'll see later. But these are the four basic data types that are supported by the C language: int for integers, float for real values, double are also real values, but with say double precision, and char is nothing but single characters. The latest C standards also support Boolean, but we will not consider Boolean in this session. But latest C language standards like C11 support Boolean also. Derived data types, they are arrived at by combining these new data types. The derived data types are array, structure, union, function, pointer, etc. For example, array is a collection of integers or floats or doubles or characters. Array is a derived data type, but it is nothing but a collection of integers, float, double, char, etc. So that means they are to be of the same data type, but you have what are called as collection. So similarly, you can have the definitions of structure, union, function, pointer, etc. We'll discuss at appropriate point, but they are the derived data types. And user defined data types you can define using what is called as type def. You can see here type def is a keyword or reserved word. Original data type, something like integer, something like int, float, etc. And then new data type. For example, you want to define, say, roll number. So roll number is an integer, but whenever you are creating a new roll number, you want to, instead of using integer, you want to use roll number. So in that case, you can write type def int roll number. So that means instead of using integer, you can use roll number whenever you want to declare the variables. Void is another data type that may be considered. So void is nothing but do nothing. You can say do nothing, which has no associated values or operations. But generally it can be used along with the pointers, what are called as pointers, another concept in C language, to create the generic pointers, We'll get into the details later. So this is information regarding the data types. These are the 4 data types. So they represent, char represents the characters, int represents the integers, float represents the real values, and this double also represents the floating point or real values, but with the double precision. The size is like this. Again, it may vary from compiler to compiler. Okay, but typical size is char is 1 byte, integer is 2 bytes, float is 4 bytes, and double is 8 bytes. Note here, it is 2 bytes means what is the range of values you can store there. So the range of values you can store is this. So these are the domain of values. Here one extra value, negative value is there because of the way the numbers or integers are represented inside a computer using 2's complement. What is called as 2's complement. You study about it in computer organization subject. But these are the possible values. Similarly, here also these are the possible values. These are the domain of values. So usually operations are not explicitly defined, it is implicit. What are the operations that can be performed? So modifiers or qualifiers. So okay, you have these basic data types or fundamental data types. You can augment them. You can augment the meaning of the basic data types. And whenever you augment, the range of values also changes, and the amount of memory that is required also changes. So 4 modifiers are defined by the C language: short, long, signed, and unsigned. So signed indicates that you are interested in the signed values. Unsigned means you are interested in only unsigned values. You are not interested in signed values. Short, if you want to limit the values, only few values are there, so you want to limit it, short you can use. Long, if you want to extend the long, that means you want to increase the size of, say, integers, etc. So characters and integers can be signed or unsigned, whereas float and double are always signed. This is the restriction in the C language. Signed means it can be positive or negative. So to represent the sign, you require at least 1 bit. Because only 2 possible values are there, you can manage with 1. Because you have only positive and negative. You don't have anything like neutral. So only positive and negative. So 1 bit can be used. That bit can be used as you like. It depends on the compiler. So 1 generally used to represent plus, and 0 to represent minus. So that means 1 bit, maybe the MSB bit, most significant bit of a binary number. 1 bit is represents the sign value. So if you go with the sign values, the range of values reduces, it becomes approximately half. So signed char can take the values from -128 to +127, whereas Unsigned char, if it is permitted, it takes the values from 0 to 255. 0 to 255. Signed in takes the values from minus 32768 to 32768 plus 32767, minus 32768 to plus 32767. Whereas if it is unsigned in, it takes the values from 0 to 65535. So you can see here approximately half, because one bit goes, that to the MSB bit goes. So qualifier short and long can be applied to all basic data types except char. Size and range of values changes. The general rule is size of char is less than size of short, less than size of int, less than the size of long. That is the general rule. But sometimes short and integer may occupy same amount of memory also. So usually short and integer occupies both occupies 2 bytes only. But in some compiler, integer may occupy 4 bytes and short may occupy 2 bytes. So you can use this function or operator, this is actually called as operator, to know the size of the integer, character, etc. Size of any data type you can know using this size of operator. We'll see in the programming. So similarly, size of char is less than size of short is less than or equal to size of float is less than or equal to size of double. So a short may occupy less memory, but it's not mandatory. It varies from compiler to compiler. Long occupies more memory when compared to the short and integer. In C language, char can be stored in an integer data type. So it is permitted only in C language. So it is continuing, historically it is continuing. So you can store character within an integer also. So because every character will have an integer value associated with it, depending on its position in the ASCII table. It will have its value. Say some character A has ASCII value 65. So because it is numerical, you can represent it in using integer also. But as a programmer, it's better you restrict yourself to char only. Char can be used to represent the characters. So some compilers permit the qualifier long to be applied to float or double also. It depends. So this is regarding the data types. Data types. So basic data types, derived data types, and then these user defined data types. Basic data types are int, char, double, float. And derived data types you can derive. You can, by combining these basic data types, you can arrive at the derived data types like array, structure, union, etc. Type def can be used to create your own data types. Your own data types are user defined data types. Thank you very much. Aman.